Hi, this is Jared Gigi. I'll be going over my video answer for this problem. Okay, so here we go. I started on the whiteboard. I used the whiteboard to kind of keep my answers separate, and I'll be going over all my work on this paper. So very first, I wrote out the top equation of iron oxide plus carbon monoxide produces iron and CO2. And because I didn't know the ratios, I left these blank, and I then wrote down everything that the problem gave me. 2.66 grams. I knew I had excess carbon monoxide. I did not know grams of iron, but I knew all of this information for carbon dioxide. So very first, using all of this information of the volume, temperature, and pressure, I was able to get the number of moles of carbon dioxide. You just use PV equals nRT, plug that in, that gives you 0.046 moles of carbon dioxide. So then you have to use that to figure out the mass of the iron. So you can figure out the mass of carbon monoxide. You use the 0.046 moles, multiply it by the molecular weight, that gives you 1.3 grams of carbon monoxide. Do the same thing for CO2, 0.046 moles times the molecular weight gives you 2.02 grams of carbon dioxide. And now we know from the, conservation of mass, that the number of reactants has to equal the amount of products. That has to be equal. So we know that if I add these two and these two, they need to be the same. I'm looking for this one, so I have these two, 2.66 grams and 1.3 grams. Add those together, subtract the 2.02 grams, that gives you 1.94 grams of Fe. So that's my answer for A, 1.94 grams of iron. So let's go on to B. B is asking me to find the ratio of the iron oxide for that formula. So all you need to do for that is, where did I start? Okay, right here. I had moles of iron, 1.94 grams times the molecular weight gives you 0.034 moles of iron. The ratio of iron to oxygen is Fe to O. It's 0.034 to the 0.046 that I found earlier. You divide by the bigger number, that gives you 0.739, which is about 0.75 to 1. You take that to a whole number ratio, that gives you 3 to 4. So my answer for B is Fe3O4, iron 3O4. Let's move on to C. C is asking me to find the number of iron atoms and oxygen atoms in the unit cell. So I have mass equals volume times density. So the mass of the iron oxide equals the volume of the unit cell times the density. The volume was 839, that was given 839 picometers times 10 to the 12th meters cubed, because it's a volume, times 5.2 times 10 to the third kilograms to the meters to the negative third. That's the density. You do that math and you get 3.071 times 10 to the negative 24th kilograms. That's the mass of iron oxide in one unit cell. So to change that to moles, you then take our answer, multiply it by the molecular weight, then convert it from kilograms to grams, and that gives you 1.326 times 10 to the negative 23rd moles of iron oxide. Take that answer that we just found, moles of iron oxide, multiply it by Avogadro's number. That will give you the number of molecules of Fe3O4. So that's 8. So we know that there is also 3 iron atoms per molecule and 4 oxygen atoms per molecule. So 8 times 3 is 24, 8 times 4 is 32. So that gives you my final answer of 24 iron and 32 oxygen in a unit cell. Thank you.